Be doing Euclidean geometry for grade 10. So we're dealing with shapes that have four sides, like kites, quadrilaterals, squares, rectangles, and so on. I hope you learned about those at school before watching this video. So we will know what we have to know what qualifies a parallelogram to be quadrilateral and all those stuff, cyclic quadrilateral and all that. So today I'll be doing this question. This will be the first one, and then we have this question 7 as the second question, which is 14 marks, and then we have this one of question 8, which is 16 marks, where we are going to prove if the opposite angles of a quadrilateral are equal or opposite side of a parallelogram are equal. So without wasting any time, let's tackle this first question for 6 marks. Right, here we have our first question. So here it simply means that QR is the same as SR, right? And then PQ is also the same as PS. So we are given OS as 2 centimeters, and we are asked to calculate OQ. So OQ is here, and we are given that this side is the same as this side. This bisects, so it cuts the kite into 2, right? So what we're gonna say here is that OQ equals to 2 centimeter, and then your reason, the reason is that this long diagonal of a kite bisect the short, this is the shorter diagonal. So that simply means that it cuts it in half. So it means this side is the same as this side. So that's going to be your reason. The long diagonal of a kite bisects the shorter diagonal. Yes, there you have it. The reason is the long diagonal of a kite bisects the shorter diagonal, which means that long one cuts the kite into 2 and then also bisects the small one. So it means both the sides are equal. So OS is the same as OQ. That's what it simply says. So 8.2, we are asked to calculate the size of O. When you are given POQ, where it's written, there's a cap on top, you know that that is the angle that you are going to calculate. So that's what it means, grade 10. So 90. So can you see that this forms a 90 degrees here? It makes it's a right angle, and this one is also a right angle. So O P O Q, now we're looking for O, I've indicated with this cap on top, equals to 90 degrees. And the reason is that the diagonals of a kite intersect at right angle. Yes, that is our reason. The diagonals of a kite intersect at the right angles. So now we are asked to calculate angle P. calculate angle P for 8.3. So angle P equals to 20. Why? This longer diagonal bisects the angles of a kite. So it bisects, it cuts the angle of a kite into two, which means this whole is 40. This whole angle is 40. So it was cut into two. And then that's where we're going to find that P QPO equals to 20 degrees. It means this one equals to 20. So that diagonal bisects the angle, which means it cuts it into two. Yes, the longer diagonals bisect the angles of a kite. So that is the reason. So we are done with this one. I hope you understood this question. Let's go to the next one. In question 7.1, we have this shape here, a rhombus. In the diagram below, PQRS is a rhombus. Calculate the size of angle X, Y, and Z, where PQ equals to Z and PQS equals to X and QSR equals to Y. So we have to find the values of X, Y, and Z for 6 months, 6 marks. So let's do that quickly. Here we are, and we have to calculate X, Y, and Z. So we are going to start with Z. Diagonals of a rhombus bisect. So which means this angle has been cut in half, this one has been cut in half, and this one has been cut in half, and this one has also been cut in half, right? So X equals to 33 degrees because diagonals of a rhombus bisect. Yes, the reason is diagonals of a rhombus bisect angles. So that is why X will also be equals to 33. So now you will be asked to calculate Y. So Y will also be equals to 33 when you look at this. Opposite angles, opposite sides of a rhombus are equal. So this angle equals to this angle. So this 33 equals to this one. So that will be the reason why Y will also be equals to 33. There you have it. Opposite sides of a rhombus are equal. So hence we are going to have 33 here and 33 here. So now we are looking for Z. For Z, let's take this triangle PQR, this one, or we can say RPQ. In this triangle, here Q equals to, we are just going to say 33. Let's calculate. 33 plus 33, that will give us 66, right? So when we have 66, this on this triangle that we have here, yes, we have P triangle RPQ or QRP, it doesn't matter. So Q is 66, right? If you look at this triangle correctly, you will see that it's an isosceles. And an isosceles triangle means these two sides are the same. Just as we said, opposite side of a rhombus are equal. So this and this are the same in this triangle, right? So it means that Q equals to 66. So we'll say a sum of a triangle is 180. So 180 minus 66, and then you will get 180 minus 66. You will get 114, and then you divide it by 2 to get this size, and that is going to be 57 degrees. So Z equals to 57 degrees, and that the reason will be sum of a triangle. So that will be the reason why Z is equals to 57. That will be sum of a triangle. Yes, we are done with that. Let's go to the next question. 7.2. So for 7.2, we're going to calculate the perpendicular height of triangle ABC. But yes, let's do it so that you guys can see. You see that DA and CE are parallel. So let's do this question first. Okay guys, this is the question that we have to do. So 7.2.1, we have to calculate the perpendicular height of triangle AB. And let's see what is ABE. And then 7.2.2, if AD equals to 10 centimeter, calculate the area of triangle ADE. And then we'll calculate the area of the trapezium A, B, C, and D. So let's do question 1. All right, so we are asked to calculate the perpendicular height of triangle A, B, and E. So EB is 8 centimeters, and then that perpendicular height is this one. This is perpendicular, right? So this is the height that we asked to calculate, which is the length, and this is the breadth. Yes, so we are asked to calculate that, and we are given that the area of this triangle in our information, as you have seen when I showed on screen the information pertaining in this question, that the area of triangle ABE is 16 meters squared, centimeters squared. So what we are going to do, we are going to use the formula of area to calculate this length, because for us to get the area we need AB and EB. So we're given the area. So area of triangle ABE equals to 1.5 BE times AB, right? So this is the area of that triangle. So we can substitute all that we have. For area here we have 16, 1/2, and then for BE we have 8 centimeters, and then times AB. So this is gonna be 16 equals to 4 times AB, and then no, we're going to time all of this will be 4AB. So we'll divide by 4 on both sides to get AB by itself, and then 4 equals to AB. So the height there is 4 centimeters. So the next question is that we calculate the area of triangle A, D, and E, this triangle. We are asked to calculate its area if this one is equals to 10 centimeters. So that area will be area equals to 1.5 AD times AB. So this is AD, this is AD, and then AB. So what we are going to do in this, we need the angle of A, D, and E. And this triangle, we use that height for this triangle. From here to here is exactly the same as that height of AB, right? That height applies for this triangle. If you do a line here, it will still be the same as that 4 centimeters. So that is the height that we are going to use. Do not be confused, Samira. There's no height. No, there is height. That height applies for this triangle as well. So it's gonna be 1.5. It's 10. So for AD, we're going to, it's 10, and then we times that by 4, and we will get the area as 20 centimeter squared. So that area is 20 centimeters squared. Now I'm going to erase the top part in order for me to do the last question. Alright, so we are asked to calculate the area of the trapezium here. So we have DA, that trapezium is A, B, C, D. So we have DA as 10 and then EB as 8. So we can calculate so this one CE is parallel to this, so this will also be 10 centimeters, but the whole thing will be 10 plus 8. So the area of this trapezium will be 1/2 sum of parallel sides times perpendicular height. That will be the area of a trapezium. So this will be 1/2. This DA is 10, and then here CE will also be 10 plus the EB 8, and then the height is 4. When you put that into the calculator, you will get 56 centimeter squared as the area of the trapezium. Now let's go to the next question. This is the next question that we have to do, 8.1. So, sorry. Complete the following sentence. If the opposite angles of a quadrilateral are equal, then the quadrilateral is a parallelogram. If the opposite sides are equal, that is a parallelogram. So I've answered 8.1. Now we're gonna do 8.2 and 8.3. Right, here is the question, and we have to prove that opposite sides of a parallelogram are equal. So the only way for us to prove that is to bisect this parallelogram with that line, but it was already given. If it's not given, then you have to write it, bisect it, though it will give you an extra sheet where these shapes are drawn, and that is for you to do they're expecting you to add to that drawing. So if you are given an extra sheet and you are given a parallelogram, you can bisect it when you are asked to prove that opposite sides are equal, because you have to have triangles in order to prove that this parallelogram is the sides of this parallelogram are equal. You need to prove congruency. So that's what we are going to do now. All right, so we're having two triangles here, and we have to prove their congruency. So triangle AB, that's triangle D, sorry. That's triangle A, B, and D. And then the other one is triangle C, D, and B. So D1, this sides are parallel, so you can use fun to identify these angles. So when you draw from here to here and here, you'll find that this angle is the same as that angle, right? And when you start from here, and then you go there, you'll find that you're going to get a Z. And then, so what you're going to say is that D1 equals to D2, right? This is D1. If you go like, sorry, let me draw this correctly. All right, let's start on a clean canvas. These sides are also parallel. Now when you go from here and draw a Z, and then to this line here, and then to that line there, you'll see that D1 is equals to B2, and that is alternating angles. You can write it in foot or shorten it, but I am going to write it in short. And then the other one is that when you go from this, they are also parallel. When you go from here, you're going to find that D2 is also equals to B1. So B1 equals to D2, and that is also alternating angles. You can also write angles like this. That means an angle. And then this side, for both these triangles, it's the same. So here we will say BD equals to BD, and that's common. That's the reason. Common, how? This triangle ABD shares this line here, BD, and even this one of CBD shares this line. So that line is common. We are proving that these triangles are the same congruency, and that's how to say these opposite sides are equal, and that will be proved with alternating angles. And then here you will say, therefore, triangle A B D equals to triangle C D B, and that's A, and that's AAS. That's what you have, side angle, right? So that's what AA is, angle, side, right? You can write it, it's either side angle, or angle, side. It's not, there's nothing wrong with that. And then here you just have, therefore, AB, this one, AB equals to DC. DC is that line, and AD equals to BC. So you have totally proven that opposite sides of a parallelogram are equal with those easy steps. Yes, you have proven with those easy steps that opposite sides of a parallelogram are equal. So we are going to do the last question, which is 8.3. The last question, 8.3, we're going to do 8.3.1 to show that M angle O equals to 90 and to prove that O is the midpoint of KP. Let's do that fast without wasting any more time, and that will be our last question. All right, here we are, guys. So we have to prove that NOM, that angle at O, the alphabet that has the sign, it means it's the one that we are looking for. So NOM in this triangle, this O, we have to prove that it's equals to 90 degrees. So the first thing that we can do here, we're not doing anything, as you can see, but what we can possibly do for 8.3.1 is that we can let N1 and N2 be X. So here we are going to let N1 equals to N2 equals to X. So it means they are both X. And the reason for that is because if you can see that N, K, and M forms a triangle, if you were to bisect this parallelogram, you will see that this bisects. So it cuts, this ON cuts this triangle into half. I don't know if you see that. So here is the reason is ON bisects K and M. That is the reason. So another thing that we can do is to let M1 and M2 to be Y. So we'll let M1 to equals M2, and they will both be Y. And that is the same reason. As you can see that PMN is bisect by OM. And then that is OM bisects NMP. That is the reason Why? I will let them, because this thing, it means it's been cut into half, right? There is a bisect line, so it means it's been cut into half. So whatever that is here is also here. And then after doing that, these lines are parallel, even though it's not written, but they are parallel lines, as we know. So we can say these two angles are equal to 180, and that is cointerior. So you know that the U in the fun equals to, I hope you did this in grade 9, because grade 8 and grade 9, you do fun in this new curriculum. So yes, so we'll say 2x equals to 2y. Sorry, 2x plus 2y equals to 180 degrees, and that is called interior angles, because KM is parallel to PM. That is our reason. So therefore, x plus y equals to 90 degrees. So if we were to take one x and one y, we will get 90 degrees. So the next step that we can make is that this is 90, this is 90 as well. So what we can do, we can say O2 is O2 plus 90 equals to 90 degrees. So O2 plus, x plus y, not, you're going to say O2, this O2 plus x, which one, n, yeah, plus x plus y, right, equals to 108. Sum of a triangle. A sum of a triangle is 108. So a triangle has to be equals to 108. Right? So we are going to write that O2, this is O2, and then we have 90. So here is 180, right? So 2x, again, x plus y equals to 90. Another x plus y equals to 90. So that makes it 108. So x plus y equals to 90, right? So it means when we have x plus y like this, we have 90. Not that x is 90 and y is 90. So x plus y equals to 90. Because this is 2x, this is 2y. So you divide that by 2, you will get 90. So which means the first x plus 2 equals to 90. This x plus this y equals 90, and this x plus this y also will equal to 90. So we are going to say O2 plus 90 equals to 108 degrees. I mean, that was sum of a triangle or interior angles of a triangle equals to 108. For this one, it's still perfectly fine. So when we move this into that, it's going to be 180 minus 90. Then we have proved that O2 equals to 90 degrees. So you see that is 6 marks, and you have proved that O2 is equals to 90. Let's go to 8.3.2. All right, we're going to show that O is the midpoint of KP. This is our last question. So for that, we are going to show that these sides are parallel and these ones are parallel. So the first thing you can notice is that when we do the Z, is that N2 equals to O1, and that is alternating angles. Alternating angles. That is the reason, because KP is parallel to NM. That's the reason, and then the which automatically says that O1 equals to N1. Put this indicates that it's an angle, and then therefore that will be, therefore KO is equals to KN, and that is opposite sides are equal. Opposite sides of a triangle are equal. So we're going to say O3 equals to M1. That is still the same thing where we do the Z. So that is alternating angles. And then the next thing we are going to say, therefore, OP, just like here, is equals to PM. Opposite sides are equal. Equal. You can write it like this as well. Yes, and then so you're going to say Kn equals to PM, and that is the opposite side as well, and therefore KO equals to OP, and just like that we have proven that O is the midpoint of KP. Thank you very much for watching. Until the next video, thank you and bye. This is the next question that we have to do, 8.1. So sorry, complete the following sentence. If the opposite angles of a quadrilateral are equal, then the quadrilateral is a parallelogram. If the opposite sides are equal, that is a parallelogram. So I've answered 8.1. Now we're gonna do 8.2 and 8.3. Right, here is the question, and we have to prove that opposite sides of a parallelogram are equal. So the only way for us to prove that is to bisect this parallelogram with that line, but it was already given. If it's not given, then you have to write it, bisect it, though it will give you an extra sheet where these shapes are drawn, and that is for you to do they're expecting you to add to that drawing. So if you are given an extra sheet and you are given a parallelogram, you can bisect it when you are asked to prove that opposite sides are equal, because you have to have triangles in order to prove that this parallelogram is the sides of this parallelogram are equal. You need to prove congruency. So that's what we are going to do now. All right, so we're having two triangles here, and we have to prove their congruency. So triangle A, B, that's triangle D, sorry. That's triangle A, B, and D. And then the other one is triangle C, D, and B. So D1, this sides are parallel, so you can use fun to identify these angles. So when you draw from here to here and here, you'll find that this angle is the same as that angle, right? And when you start from here, and then you go there, you'll find that you're going to get a Z. And then, so what you're going to say is that D1 equals to D2, right? This is D1. If you go like, sorry, let me draw this correctly. All right, let's start on a clean canvas. These sides are also parallel. Now when you go from here and draw a Z, and then to this line here, and then to that line there, you'll see that D1 is equals to B2, and that is alternating angles. You can write it in foot or shorten it, but I am going to write it in short. And then the other one is that when you go from this, they are also parallel. When you go from here, you're going to find that D2 is also equals to B1. So B1 equals to D2, and that is also alternating angles. You can also write angles like this. That means an angle. And then this side, for both these triangles, it's the same. So here we will say BD equals to BD, and that's common. That's the reason. Common, how? This triangle ABD shares this line here, BD, and even this one of CBD shares this line. So that line is common. We are proving that these triangles are the same. Congruency, and that's how to say these opposite sides are equal. And that will be proved with alternating angles. And then here you will say, therefore, triangle triangle CDB, and that's A, and that's AAS. That's what you have, side angle, right? So that's what AA is, angle, side, right? You can write it, it's either side angle or angle side. It's not there's nothing wrong with that. And then here you just have, therefore AB, this one, AB equals to DC is that line, and AD equals to BC. So you have totally proven that opposite sides of a parallelogram are equal with those easy steps. Yes, you have proven with those easy steps that opposite sides of a parallelogram are equal. So we are going to do the last question, which is 8.3.